Okay, so that wasn't too bad. 90 seconds was a little bit optimistic. It took probably closer to a little bit longer than 90 anyway. But we have our notebook up and running, or sorry, our cluster up and running. And the next step is to actually access the web interface. I should again highlight how much effort this takes off of you, the app developer, the administrator. We have not had to do too much other than a couple of shell commands. You didn't have to download software and install it and configure it and. We just ran a couple of things and life is good. So I clicked the cluster. And one thing I should note here too, in our cluster, we see that we have two worker nodes. So basically we have two machines dedicated to processing for us. So that's going to be useful. And we are going to go right into web interfaces. And we have some information here. So we could SSH in. We could use Yarn. We could go into MapReduce. We could look at our Spark history. We're going to click Jupyter Lab here. And we're going to get a kind of a unique-ish ID looking thing here. So we have a nice web-based interface to a Jupyter notebook. Well, we're going to create the Jupyter notebook. We're in Jupyter Lab, which allows us to create Jupyter notebooks. All right, so we want a Python 3 notebook. Note you could do PySpark, Spylon, basically whatever you would like. You can even just use a text editor if you want. Be a little bit of an overkill type of thing. Cannot read property path of undefined. Interesting. Okay. I think I clicked that 3 times. The third time it worked. Must have still been spinning up in the background. Okay, so we now have a notebook. Oh, you know what I did? I bet I know what I did. Okay. So the lab is slightly different. Let me close this here, and I just want to show you what happened. So I am not in any location. All right, yeah, okay. CodeLab's a little bit different than what's going on here. I'm just clicking Python 3 and it's giving me a 403 error. It doesn't know where to store this thing. You're getting a forbidden response from the server. I double click GCS for Google Cloud Storage, and then you can create it. Basically, you have to put it in the correct location. Not noted here in the lab, at least as far as I'm aware. So I'm going to rename this notebook, and what do they want us to call it? Just so that we stick with their thing. Oh, that's a lot to type. BQ, BQS, and Spark DF. Okay, so we have a notebook now. Yes, we want Python 3. Do have other options as well. So we now have some code here to write. All right, so if I want to, we can check. Let's show some commands here quickly. Print hello CIS680. See, so I can basically click play, and it's going to run that code. I could say for I in range 50, print hi again, CIS680. And we can be Pythonic about this. V0, and I'm just kind of riffing here. I'm not really doing anything from the code lab. Okay, I can add another cell. And I can set code or markdown, so let's make this a header. The above code is utterly useless unless if you're learning Python. Okay. So if I run that, hey look, it's formatted as a markdown header. If I run this, I'm going to get a whole bunch of code output. So basically we're just kind of messing around here. So we can clear all of our outputs. And let's get rid of these cells. So delete cell, delete cell, delete decomedy. I didn't notice I'm just gonna use the mouse because I'm not horribly familiar with this particular syntax, but basic thing. So let's check our version of Scala. That's an exclamation point, not a not a colon. So there's our code runner, 21112. Good enough. All right, so I'm just trying to check to make sure that we're going to follow along because they've got a lot of code in here. And I want to make sure that we use the right one. But following along, that's working. Okay. So from PySpark.sql import Spark session. Again, pure Python code. Spark session.builder. Let's follow their formatting. .app name, BigQuery. We'll follow our name. BQS and SparkDF. And .config and .get or create. All right, so we want this code here, and we'll copy everything, and it says that we have to do something special in the event of one versus the other Scala version. So if we are using 2.11, we want this package. Let's make sure that's the same one. That looks about right. If you have 2.12, use this one. So I think we are okay. So run that. And we can set a configuration here. So spark.conf.set, spark.sql.repl.eager.eval.enabled true. Okay. And now we're going to get some info from the public data sets. So basically Wikipedia page views from 2020. We're going to get it in BigQuery format, and we're going to filter it based on basically the timestamp here. And then we're going to print the schema. So let's run this. Let's run this. And then run this. And to run, I'm just clicking this play button here. And we actually saw this little dot kind of do something while we were waiting. And then we have our schema here. So this is not data, this is just what the data is formatted as. Right, and we actually see the output there. All right, so now what we're going to do is we're going to do a select statement and just print out our data frame. This isn't necessarily a class on learning about data frames and the particular formatting of big data, but just be aware that as one of the approaches when you are working with data sets is to turn it into a data frame. Very helpful if you decide you want to go the route of learning, say, pandas or R or something like that. So we're going to run this, and we see it active right here. Depending on your instantiation of Jupyter, this used to be a green circle, but it's still running, so we can let that cook for a moment. There we go. Didn't take that long, but it had to chunk through a ton of data. And here's our page views. So 143,159 page views at 4 p.m. on March 1st. And yes, I did have to mentally go through in my head. It's been that kind of day. All right, so now let's group by the title and group by, in order by the page views. Let's check out what this is going to do now. And what we are really doing here, just to kind of set the context, we are generating data, yes, but we're generating data via Apache Spark talking to BigQuery. We have worker nodes chunking out this data very, very quickly. If you were to run these commands on a standard SQL type of environment, it would pretty much choke. A lot of information to go through. So here's our views or grouped on the date hour. So there we go. All right, so again, this is a data frame. This is an object for basically aggregating data in some format. It's going to be a tabular type of format, but this is very useful when you need to manage a data set of some kind. And data frames are something you should become intimately familiar with if you want to go the analytics route. But maybe you don't like Spark. Maybe you want to convert this to a Pandas data frame. And Pandas is one of the Python libraries which are absolutely wonderful for managing data in tabular data, but really any kind of data. I've used it a lot for like statistical data processing if I need to look at data sets and compare them. But a lot of people really like them for just working with a massive amount of data. So what we can do is we can actually make use of pandas as well. And I guess I should mention this too. I've also used pandas for plotting. It makes very pretty figures in comparison to some of the standard like matplotlib packages that are out there. But we're going to convert it to a pandas data frame, and we just have a simple Python call for that. So we're going to get some info and then plot it. And we are going to use, interestingly, matplotlib. I forgot about this aspect. You can do prettier plotting in pandas, so not sure why we're going over here, but why not? So let's go ahead and now plot this data out. And we should get something that looks kind of like this. All right, what's the hotkey for running? Shift Enter. Okay. I like hotkeys. Shift Enter. Okay. And then we can plot our line graph. And if you get good with Python, you can do any kind of plot that you want, really. Lots of nice, pretty plots, simple line graphs, histograms, violin charts, whatever you need to do. Okay, so we have a plot. In theory, if I wanted to, say, give this notebook to other people or share it with them, this would be a little bit more approachable than, say, giving somebody a Python script to chunk through data. And this is purely the Jupyter side of things. Obviously, working with Spark and all of these other cloud-based tools are nice, but Jupyter notebooks are kind of nice in and of themselves. Let me insert a note here. I can say something like create Spark object. And this is Markdown. And I can insert a node here, or a cell here, Markdown. Create Spark data frame. I can run this, and I can run this. And now I've got basically text describing what's going on here. And I can go down here a little bit. So let's go to our Spark node. Let's add another cell. The next bit shows some information about, or the next bit creates a pandas data frame from a Spark data frame. Ran out of text to write. Oops, that's okay. Doesn't like my jargon or my slapped on the keyboard syntax. So let's not put any special characters in here. Oh, Markdown. Okay, that was my fault. So just some text. I can write like lab reports in Pandas, or sorry, in Jupyter as well, which is really nice. So I could write like an entire lab manual, and then rather than copying and pasting a chart from somewhere else, I just generate it here and save this off as a PDF. Okay, so let's go back to our Cloud Shell, and if we look inside of our bucket, so we do gsutil ls gs bucket name /notebook/Jupyter. Here's my Jupyter notebook. Should mention, if you are running a Jupyter notebook server yourself somewhere else, you could probably copy and paste this. Now the hooks to BigQuery and all that aren't going to work without extra effort, but if you want to save it elsewhere, that is definitely possible. We can even look inside our straight up bucket here, and we're going to see our notebooks, and we even see some DataProc info as well. All right, getting a little bit long in the tooth here for this video. Let's minimize this, and we can see our memory usage. So we got up to 22.4 gigs of memory about in Yarn. So keep in mind that's how much data we're chunking through. All right, I'm not going to necessarily go through the rest of this since we are getting a bit long, and this is mainly working with data frames. We can work in memory rather than basically using calls to BigQuery every time. Maybe we want to reduce our dependence on BigQuery. We just want to work, again, in our local memory. So that is possible. We have some Jupyter Notebook code here, which will help us with that. Basically, we're just caching in memory instead of constantly reading. Can be helpful if you would like, but we've kind of hit the main purpose of the lab, which was to get you up and running with DataProc, kind of have that be automatically created for you, and then, hey, realize that you can actually create Jupyter notebooks from that. If you want to play around with this some more, this code lab has some extra links here for you. Maybe you want to play around with Spark data frames a bit more. Maybe you want to play around with Google Cloud Storage. Maybe you want to play around with pandas plotting a little bit more. So get some nice links in here to take you to some other examples. And this one that I just clicked, it actually is a full Jupyter notebook. So you can actually kind of see what is available here. And I should note, if you click go to file, you should be able to export it as a raw file, not the pretty, yeah, here we go. There's the actual stuff. But anyway, hope this was interesting for you. I like Jupyter notebooks. I think there are have lots of possibilities for interesting behaviors, I suppose. And being able to use them to talk to BigQuery in a very highly efficient manner is something that tickles my fancy as well. So I hope you all had a good demo here. I'm going to go ahead now and clean this project up by simply deleting it so that I don't get charged anymore. But I will see you all in the next video. Bye, everybody. And I wanted to delete, not clear. There we go. All right. Goodbye, everybody.